Okay, so here we have another improper integral, and so this time the integral is the integral from -1 to 1 of e to the x over e to the x minus 1 dx. Now, if we see here, if you notice when we plug in 0 for x, we have a 0 denominator, and because we cannot have that, we have to split up this integral into two separate integrals. So we can say that this is equal to the integral from -1 to 0 of e to the x over e to the x minus 1 dx plus the integral from 0 to 1 of e to the x over e to the x minus 1 dx. Now, what we have to do, because when we plug in 0 in both of these integrals, we have a 0 denominator, what we have to do is we have to substitute 0 for a variable, and then we have to take the limit of that variable as it approaches 0. So what we'll do is we'll say that we'll just call a variable a, and we want to take the limit of this from the negative direction because this is from -1 to 0, and then so the integral of -1 to a of e to the x over e to the x minus 1 dx. And then we'll do a similar thing here, so it'll be plus the integral of the limit as b approaches 0 from the positive direction this time. And then so this will be the integral times of the integral of b to 1 of e to the x over e to the x minus 1 dx. Now, to solve this integral, we need to do a u substitution, and we will use e to the x minus 1 as u. And when we differentiate this, we get e to the x equals e to the x dx, equals du. And then we can plug this back into this up here, and we will get that the limit as a approaches 0 from the negative direction, from -1 to a of 1 over u du plus the limit as b approaches 0 from the positive direction of b to 1 of 1 over u du. And then when we solve these integrals, what we have is, so this right here is equal to the limit as a approaches 0 from the negative direction of ln of the absolute value of u evaluated from -1 to a plus the limit as b approaches 0 from the positive direction of the ln of the absolute value of u evaluated from b to 1. And then now when we plug u back in, what we have is the limit as a approaches 0 from the negative direction of the ln of the absolute value of e to the x minus 1 evaluated from, this is the absolute value, evaluated from -1 to a plus the limit as b approaches 0 from the positive direction of the ln, the absolute value of e to the x minus 1. That will be evaluated from b to 1. And then now we can expand this, and so when we expand this, we have the limit as a approaches 0 from the negative direction of the ln of e to the a minus 1 minus the ln of e to the negative 1 minus 1, and then plus the limit as b approaches 0 from the positive direction of the ln of e to the 1, so e minus 1, minus the ln of the absolute value of e to the b minus 1. And then, so when we evaluate these limits, now that we have everything solved out, we can evaluate these limits. And what we find is we have negative infinity for this because ln can, or the natural log cannot equal 0. And so negative infinity minus the natural log of e to the negative 1 minus 1 plus the ln of e to the 1 minus 1 minus negative infinity. And so because we have infinities in our solution, this integral does not converge, it diverges, and we cannot find the area.